So in this video, we're going to be going through an exam style question, and part A starts with given x cubed take away 5x squared plus 2 equals 0. So we're given a cubic equation. Show that x is equal to the cube root of 5x squared take away 2. So what we need to do is to show how you rearrange this equation into that form. If you can't spot it, my top tip is thinking about starting with where you need to get to. Can you rearrange that into that form? And quite often it's easier to spot that. So to get rid of the cube root, I'd need to cube both sides, and then I could subtract the 5x squared and add 2 to both sides. So if we reverse the process there, so for part A, starting with x cubed take away 5x squared plus 2 equals 0. If we add 5x squared and subtract 2 from both sides, then we cube root both sides, we have what we wanted to get to. Okay, so as required. Then for part B, find an approximate solution to x cubed take away 5x squared plus 2 equals 0 using the iteration xn plus 1 equals the cube root of 5xn squared take away 2. So they've replaced the x with xn plus 1, they've replaced that x with xn. Start with x1 equals 6. Give your answer to 4 significant figures. Okay, so starting with x1 is 6, I'm going to type 6 into my calculator and then press equals. That puts 6 into the working memory. Then I'm going to type this in using replacing the xn with the answer key on my calculator. So one way you could do that is you could type in bracket 5 times answer squared take away 2, and then cube root is the same as to the power of a third. Okay, so 5 times answer squared take away 2, close the bracket to the power of a third, and then press equals. So what you should be getting is that x2 is 5.625 226328. Okay, now if you keep pressing equals, now you want to keep pressing equals a lot here because it's homing in quite slowly. The numbers are changing ever so slightly, okay? But what we want to do is we want to give our answer to 4 significant figures, okay? And so essentially you just want to go as far along as you need to until the number of significant figures that you need isn't changing. So 4 significant figures, I've managed to get to 4.917286.018. So x equals 4.917 to 4 significant figures. Okay, and so that is the answer I'm looking for.